Hi, welcome back to my channel, and today's lesson is about the Thevenin's theorem. And in this lesson, we will know what the Thevenin's theorem is. We know how to calculate for the Thevenin voltage, definition for Thevenin voltage. We know the definition for the Thevenin resistance and how to calculate for the Thevenin resistance. Okay, Thevenin's theorem. What is the Thevenin's theorem? The Thevenin's theorem states that any linear two-terminal circuit can be replaced by an equivalent circuit consisting of a single voltage source in series with a single resistor. In simple terms, most people don't actually understand the Thevenin's theorem. So let me break it down to you. It's like we have a complex circuit consisting of many batteries, many resistors, and we want to break it down, or we want to break it down so that we can find the exact current output of that circuit. So we will place those many batteries with a single voltage source, as well as replacing those many resistors with a single resistor. So what is a Thevenin voltage? A Thevenin voltage is the open circuit voltage at the two terminals. Thevenin resistance is the equivalent resistance looking back into the terminals with all independent sources turned off. What do we mean by all independent sources turned off? This is when the voltage sources are cut short and current sources are opened. So these are the definitions of the Thevenin voltage and the Thevenin resistance. Let's get into how to solve for the Thevenin voltage, the Thevenin resistance, and the load of the output. Okay, we have a practical question, and in this question it says that imagine you have a 12-volt battery connected 12-volt battery connected to 4 resistors in a bridge. That's in a bridge configuration, right? Here is a Wheatstone bridge configuration, and you want to know how a 10-ohm light bulb will behave when attached to the output. So let's all study this diagram. We have resistor 1, resistor 2, resistor 3, resistor 4, and we have a 12-volt battery. We have our bulb or load. So how do we solve this kind of issue? So in solving this kind of issue, you have to remove the bulb, removing the load. So after removing the load, then we calculate for the voltage across the two two open terminals using the voltage divider rule. And how do we do that? So using the voltage divider rule. Okay, and secondly, it says that we should calculate for the Thevenin voltage using the voltage divider rule. So step 2, we have to calculate for the voltage T of H. You have to get V T of H. Okay. So here for the VT of H, you have to find the volt at terminal A and the volt at terminal B. And how do we find the volt at terminal A and terminal B? Let's come back here. Here is terminal A and here is terminal B. So at terminal A we have R1 and R2. So for the volt at terminal A, we will first consider the total voltage. So total voltage equal to the resistor 1, equal to resistor 2, all on resistor 1 plus resistor 2. So resistor 2 all on resistor 1 plus resistor 2. So this is how to find the voltage at terminal A. Then we find the voltage at terminal B. Voltage at terminal B is the same process. We consider the total resistance, the total voltage, then resistor 4 or on resistor 3 plus resistor 4. So after finding the voltage at the terminal A and terminal B, then we will subtract terminal B from terminal A to get Thevenin voltage. Okay. And our third step is we turn off the battery. So we remove the voltage source. That's the total voltage. We remove the total voltage source. Then we calculate for the total resistance of the remaining network. So how do we calculate for the total resistance of the remaining network? First of all, at terminal A, we have to add the resistors at terminal A. I'm naming this Rx. Then I'm naming this Ry, and Ry is adding the resistors at terminal B in series. All these are in series. Then my Thevenin resistance will have to be 1 over Rx plus 1 over Ry. This is because of the Wheatstone bridge. In the Wheatstone bridge, to find the total of the resistance, you have to first add them in series, then we add them the both sides at the terminals in parallel. So here we know that the total resistance is equal to the Thevenin resistance. Okay, so now we have our Thevenin voltage, we have our Thevenin resistance, and we have the resistor of the load or the bulb. How can we find the current? So to find the current is R of TH, that's the Thevenin resistor, over V. To find the current, it's V of TH all over R of TH adding to R, where the R becomes the resistance of the bulb. the resistance of the bulb. So here we find our load. So when we solve and we get any value that is high, it means that the bulb becomes brighter, because the higher the current, the higher or the brighter the bulb. When we get any value that is lower, the lower the current, the lower the bulb. Thank you very much. I hope you liked this video. Please subscribe for me. Bye.